The interior of the Earth is divided into layers, and we think of it as three main layers: the crust, the mantle, and the core. But each of these layers is actually subdivided into two parts. Starting with the crust, which is the outermost layer. On our cutaway, we see this portion of the crust here that's under the water. That is what's called the oceanic crust. And as you can see, that is a thinner portion of the crust, up to about 10 miles in thickness. And the composition of the oceanic crust is primarily basalt, which, if you've ever seen dried lava, that is basalt. Now, this thicker part of the crust is called the continental crust, and this is where the land masses are found. So as we saw, it is thicker, up to about 30 to 50 miles in thickness, and it is composed primarily of granite, which is lower in density than the basalt. So that is our crust. That is the outermost layer of the Earth. The next layer down from the crust is what is called the mantle. And on our illustration here, the mantle is shown running from just below the crust down almost halfway, but this part is not actually to scale, but it does extend deep into Earth's interior. And on the cutaway here, it's showing 4 parts to the mantle. We're only going to concentrate on 2 parts. These outer 2 sections is called the upper mantle. And this is where the rocks are solid. As you go deeper into Earth's interior, 2 things happen. You have an increase in pressure because all of these layers are pushing down, and the deeper you get, the more layers you have above you pushing down, so the pressure gets higher. That also is going to mean that the temperature gets higher. So it's going to get hotter and hotter as we go deeper into the Earth's interior. And that's going to affect the consistency of these rocks. And so our solid rocks really are going to transition. The gray region in here is truly solid rocks. This orange region, labeled asthenosphere, there the rocks are considered plastic in consistency. They actually can be bent as pressures are applied. So the upper mantle, we have solid and plastic consistency of rocks. The section below that is called the lower mantle, and this is where you have molten rocks, where the rocks have melted to essentially a liquid consistency. So all of this region down in the mantle, the lower part of the mantle, is molten rocks, which we call that magma when it's below the ground, or if it comes out of the earth, we call that lava. So this is our source for lava, all that molten material that comes out of volcanoes. The last of our layers is the innermost part of the earth, which is called the core. And again, we divide that into two parts. The part farther from the center is called the outer core. And our core is composed primarily of iron. A little bit of nickel is in there. But the outer core is where we have molten iron. And that molten iron is actually our source of Earth's magnetic field. Now, this is not the same as gravity. The magnetic field, one, protects us from charged particles from space, and two, is the reason why a needle of a compass points north. That's the magnetic field. And that's generated because when you have molten iron, you have charged particles swirling around in our outer core. And when you have charged particles moving in a circle, that behaves like a magnet. And that's actually a very popular science fair project, is to take a nail and wrap it with wire, stick the ends of that wire to a battery, and suddenly you have a little magnet. Your nail will be able to pick up paper clips. So if you ever want to make your own magnet, just wrap some wire around a nail and attach it to a battery. And what's happening is you have charged particles going in circles around that nail. Well, in our outer core, we have charged particles going in circles around our inner core, and it basically makes the entire Earth a giant magnet. The last layer, the very center, is the inner core, and this is where we have solid iron, which is counterintuitive. We already said it's getting hotter and hotter as we go to the center. The very center of the Earth is hotter than the surface of our sun. So that's insanely hot. Hot enough that iron should be molten. But remember, you also get more and more pressure as you go to the center. And there is enough pressure to actually force it to be a solid. It is squeezing those atoms together so tightly that they have no choice. They are forced into a solid form. So those are the layers we find inside the Earth.